Okay, before we actually get into writing things down, Friday we solved one-step equations. Today, tomorrow, Wednesday, we are going to work on solving multi-step equations, okay? To the point where on Friday, we're gonna have a quiz, okay?
Already?
Already. So we are gonna solve equations, solve equations, solve equations.
I'm gonna be sick on Friday.
You think so? Okay, yeah. Okay, all day?
From 7 to end of 8.
You won't be? Okay, so if it were the case that you were like only gone in the afternoon, we could like take your quiz during flex if needed. Okay. All right. So when we have more than one thing we have to do in the equation, okay? These are things that I want to make sure that you follow, okay? So we're gonna talk about what steps we need to take. Okay, so step number 1, if there's anything to distribute, then I want you to do that first. Distribute. So you have a number outside a set of parentheses and you multiply it through. Okay. Then I need you to look for any sort of like terms that you need to combine. On the left side, do we have any terms we need to combine? On the right side, do we have any terms that we need to combine? Then what I want you to do, I want you to make a decision, okay? I want you to pick one side for your variables, okay? So I want you to move your variables to one side and then move all of your constants to the other side. Pick one side for your variables, pick one side for your constants, and then the rest will go pretty smoothly. So we're just going to solve some equations today, and we're going to talk about some different things that may come up in a problem that we need to look out for. Okay. Yeah. Yes. Okay, so on the top shelf, I have like a rainbow clear container. Just open that up and grab one, okay? Are you okay? Yeah, are you okay? Okay, so I want you to flip the page to page 10. Flip the page to page 10. Okay. Now we're going to start with number 1. Okay. Is this a problem where we need to distribute anything? No. No. Do we have any like terms we need to combine? No. So we need to just pick one side for the variables, pick one side for the constants. All right. Well, I already have X on the left but not on the right. So I think I'll just keep 3x on the left side. So what should I do with that 4?
Subtract it.
Okay, we can subtract 4 from both sides to where now we have 3x equals 15. Okay. Kaylee, what's our next step? Yeah, what are we going to divide by? We can divide both sides by 3. And so now we're left with x equals 5. You know what's really cool about solving equations? We can check our answers. If this is our answer, we should be able to plug it back into the equation and it makes sense. So what is 3 times 5 plus 4? 19. Look at that, guys. It works. Isn't that great? So great. Okay. All right, so now you and your elbow partner together are going to work through number 2.
That was 22.
We're talking about like.
That's number 2.
Huh? Did you say my name?
I said just number 2.
I swear I heard. I said okay.
All right, Kaden, what's the first thing you and Hunter did? And Brooks, I don't know why I want to call you Hunter. I'm so sorry. Brooks and Kaden. Kaden, what did you do first? All right, so Kaden added 13. Does that seem legit? Okay. Ellery, what'd you do next? So we get z equals 2. Awesome. Okay. Now, I think we should step it up a notch. Okay, good. Let's talk about number 5. Number 5. Okay. We're going to take a vote. Do I need to move the 5 first or do I need to move the 4 first? Who thinks we need to move the 5 first? Who thinks we need to move the 4 first? Okay. The 4 is like a 1/4 F. Okay. So like up here, we waited until the very end to take care of the 3. That 4 is in that same position. So this is how I like to think of it. 4 is the closest to F. It's tied the closest to F, so it's got to go last. All right. So we actually need to add the 5 first. It is like reverse PEMDAS. Okay. And so F over 4 equals, what would this be? -4. Okay. And then to get F by itself, Connor, what do we need to do? To get -16. Very good. Okay, now we're gonna go to number 6. Okay, number 6 looks similar, but it doesn't at the same time. Okay, there is still like addition, subtraction, and division. However, how is this one going to be different in terms of how we look at the problem? Okay, so notice how 3 is being divided to the entire left side. So that means we need to get rid of that one first. Okay, so we can multiply both sides by 3 right away. So now we have Q plus -5 equals 24. Okay. Now, I don't really like this whole Q plus -5 business. Q plus -5 is the same thing as what? Okay, so I'm gonna go ahead and just rewrite this to Q minus 5 because I think that that is just easier for our brains to process. Okay, because if we have Q minus 5, then to get 5 by itself, we would. We're gonna add 5 to get Q equals 29. All right, let's make things a little bit more exciting. I want you to look at number 9. I'm bored. These problems are too.
I know, they're pretty easy. They're pretty easy.
Okay, what is different about number 9? Connor? You go.
I can do it. No, yeah.
Okay,
Go for me.
Henry's gotten to talk a lot already. Okay, sorry. Okay, so there are 2 different terms that involve an x. So before we can start moving things around, we need to take 12x and 2x and combine them. So this is going to be 14x plus 4 equals 39. Okay. There, we're not going to write a decimal. So this is, we're going to subtract 4. So we get 14x equals what? 35. Okay. So some of you have already gotten to the point where we're dividing by 14 and 35 is not divisible by 14. Okay. So we're going to keep this as a fraction. All right. Now 35 over 14, is that a reduced fraction?
No.
No, because both 35 and 14 are divisible by
7.
Okay, so this would be the same thing as 5/2, which is yes, 2.5, but I would like you to keep improper fractions. Okay, that's something that I need you to get used to for next year. Okay, improper fractions are better than mixed numbers. Are you okay? Connor's having a rough day.
Somebody what?
Okay. Are we okay with this? A little bit? Okay, what are you not okay with?
I don't know.
Okay,
I'd rather.
okay. You'd rather do decimals? I'm so sorry.
I already finished them. I've already finished.
All right, let's go to the next page and go to number 11. I just said go to the next page. I didn't say turn the page. Okay, now here is an opportunity for us to actually start with the step number 1, right? Because what do we need to do? We need to distribute, okay? So this 3 needs to be carried through to where this is 3z plus 21 equals 21. Ooh. Why are we panicking?
Because 3 is not, can't really, I mean, 0 can't be divided.
Yes, it can.
Can?
It's 1.
0.
It's 0.
Okay, so, all right, let's not get ahead of ourselves. We need to subtract 21 from both sides. And when we do, we get 3z equals 0. Now we're having some arguments over here with some very interesting logic, but let's just think this through. If we divide 0 by 3, we get 0. We can't divide by 0, but we can divide into 0. Okay. What? If I have 0 items that I want to split up into 3 different piles, every pile is going to have 0 items. Okay. Okay. All right, let's look down at number 13. I like number 13. This is a great problem. Okay. We need to distribute. Now, please do not work ahead of me on this problem because I am really worried about us distributing incorrectly. What number are we distributing? No. -3. This would become 12r minus 27 plus 3r. Please be careful. Because -3 times, okay, -3 times minus r would become a positive r. Okay. Now what do we need to do?
You gotta combine the variables.
Okay, we need to combine like terms. So we have 15r minus 27 on the right side. So now we're going to add 27 to both sides. So is that 60? Okay. So now if we divide 15 to both sides, we get r equals 4. Yeah. Okay. Harry has a question. Should the R be on the left side? I don't think everybody can hear me right now. Okay. So what I did is I kept R on the right side since that's where it was. Now, you can write it like this. You can write it as R equals 4, but it does not matter either way. They mean the same thing. Who? Okay. So I'm maybe not quite as picky as Miss Otto is. I'll be flexible. Okay. But I mean, it looks better like this. Okay. Aesthetically pleasing. Okay. Yeah. Yeah, just give me a moment. Okay. Okay, you and your elbow partner, work through number 14, please.
Right. So combine the light. That's true. So.
Seven and negative eight. Yes.
Oh, I have to go.
Yes. G. We have a lot of homework to
All right, eyes up here. This is the work and answer that you should have. I am hearing a little bit of discrepancy. Okay, so I'm going to talk through this. All right.
I forgot a bag. So can I go get it?
Um,
Kyra,
that's
there's
right.
10 minutes left of class. Why don't we not?
Okay, this 3 gets distributed to make 6g minus 18. Then we need to combine like terms. 7 minus 18 is going to give us negative 11. So then we're going to add 11 to both sides. So 6g equals negative 18. Divide by 6 to get g equals negative 3. Okay, I appreciate those of you who are fixing a mistake that you had. Do you have a question about how any of this rolled out? Tell me, madam. I feel so fancy. All right. Let's look at number 16. We're going to wrap up with number 16. One angle of a triangle has a measure of 66 degrees. Okay, so we know that the measure of angle 1 is 66 degrees. The measure of the third angle is 57 degrees more than half the measure of the second angle. Okay, so do we know what our second angle is?
No.
So let's call it X.
So I kind of missed like a couple seconds of class. And what do the numbers mean in between the equal sign and?
So this is measure of angle 1 is 66 degrees. Measure of angle 2, we don't know. Measure of angle 3. 57 degrees more than half of the second angle. Raise your hand if you can give me that in a number sentence. Brooks. Nope.
X divided by 2 plus 57.
Okay. 1/2 X plus 57. Or Henry said X divided by 2 plus 57. Half of the second angle and then 57 more. Okay, Virgil, do you have a question? Okay. So now we know that the 3 angles of a triangle should add up to 180. So we know that 66 plus x over 2 plus 57 should equal 180. The sum of the angles is 180. So I made the sum of my angles equal 180.
So wouldn't it be like 66 plus 57 plus 2x divided by 2?
Okay, so let's talk about what's 66 plus 57. 123. And then x plus 1/2 x is x and a half. So could we make that 3/2 x? And we don't freak out?
Wait, how do we get 3/2 x?
Okay.
Because x plus x over
Lock it in.
1x plus 1/2 x is 1.5 x. So 3/2.
Oh, okay. Say that.
Oh.
1 x
Yeah.
plus 1/2 x is 3/2 x. Okay. All right. So now we can subtract 123. Oh.
Did you do this wrong?
No, I was trying to do math in my head. 57. Okay, now I am glad we are doing this problem because I know this came up in your homework over the weekend and I was really hoping somebody would ask about it and they didn't.
They did.
Okay, well, just something like this. Notice how we have a fraction multiplied to x. We need to divide by 3/2. Well, dividing by 3/2 is the same as multiplying by 2/3.
It is.
It is. Dividing by a fraction, we use the same thing as multiplying by the reciprocal. So notice how these cross out and we have x equals 57 times 2 divided by 3. What is it, Cassie?
38. I did that in my head. But that makes a lot.
Is this on the homework?
Now. Very good, Connor. Okay. Now, x is 38, but what does x represent? Okay, so we know that the measure of angle 1 is 66. The measure of angle 2 is 38. Well, that's okay. It's x over 2 plus 57. Well, x is 38. So if we take 38 divided by 2 and add 57, we get 78.